Volcanoes are mostly stereotypical. You've got the peaks, the constant steam, and lots of dramatic eruptions. But some of the most powerful volcanoes are totally different from that. These are silent but deadly, and you might never even see them coming, especially if they're underwater. And well, the largest underwater volcano's risk of sudden eruption has just increased by 360%, and it has the potential to destroy the entire world. Join us as we dig deeper into what's really going on and how this one volcano could end life as we know it. Volcanoes might seem like they're a thing of the past because we don't hear about big eruptions every day. However, they're still capable of causing major disruptions. One such volcano is Hunga Tanga Hunga Pai in the South Pacific. This underwater volcano sits on the Kermadec Tonga Ridge, a place formed by the coming together of two tectonic plates, the Pacific Plate and the Indo-Australian Plate. This collision has created a chain of islands and volcanoes beneath the ocean's surface. Hunga Tanga Hunga Pai is mostly underwater, with just two small islands, Hunga Tanga and Hunga Pai, peaking above the water. These islands are remnants of the volcano's once mighty calderas. The volcano's caldera, a sort of crater, lies about 490 feet beneath the sea's surface, measuring a massive 2.5 miles in length and a mile in width. Previous eruptions have shaped its landscape, making it look different each time it erupts, with evidence of eruptions going back to 1108 CE. Recently, the risk of eruption has increased because the 2021 to 2022 eruptions were unexpectedly large and powerful. On December 20th, 2021, a significant eruption occurred, producing a huge ash plume visible from Nuku'alofa. The Volcanic Ash Advisory Center, Wellington, quickly issued a warning to airlines. The eruption was so intense that it could be heard up to 110 miles away. The initial eruption lasted until the early hours of the next day. This was just the beginning. Satellite imagery on December 25th revealed that the island had expanded, which had happened before. On January 11th, the volcano was declared dormant. But then, on January 14th, it reawakened, releasing an ash cloud that reached up to 12 miles. The next day, it erupted even more violently, with the volcanic plume rising to an astonishing 36 miles into the mesosphere, setting a new record. This sudden and intense volcanic activity has made Hunga Tanga Hunga Pai a topic of concern and study for scientists and the safety of nearby communities. A massive volcanic eruption sent shockwaves across vast distances, reaching places as far as Alaska and the United Kingdom. The eruption's magnitude dwarfed even nuclear explosions. Scientists led by Sam Perkis from the University of Miami meticulously analyzed satellite data, field observations, and drone mapping to understand the eruption's scale and impact. Their findings revealed that the explosion's force was akin to a hydrogen bomb, exceeding any recent volcanic event in history. Beyond documenting the devastation, the study delved into the mechanisms that created the devastating tsunami, shedding light on the potential for future catastrophes. The volcano released an unprecedented volume of water vapor into the atmosphere, carrying implications for climate change, with the potential for temporary warming. This added to the challenges posed by existing climate change issues, contributing to extreme weather events. The eruption set records with the highest volcanic plume ever recorded, projecting ash 36 miles into the atmosphere. It also initiated atmospheric waves that traveled at an astonishing speed of 720 miles per hour, circling the globe multiple times. Researchers, including Shane Cronin from the University of Auckland, conducted ground-level assessments of the damage, witnessing the destructive force unleashed by the eruption. Downed trees and vegetation lined the coast, confirming the eruption's magnitude. The eruption unfolded in a series of blasts, starting with two relatively minor ones and culminating in a cataclysmic fifth blast, equivalent in force to significant nuclear tests. This final blast displaced seawater, creating a colossal local tsunami. The simulation showed that just 1 minute after the blast, the displaced wave measured an astonishing 85 meters in height. As it traveled toward Tonga's Tofua Island, ground observations suggested that its towering presence reached 45 meters, though experts suspected this might be an underestimate. This geological event was unprecedented, not only in its immediate impact, but also in its potential long-term consequences for the environment. The study serves as a stark reminder of the immense power of nature and the need for greater preparedness in the face of such natural disasters. Unusual events like these don't happen every day, so it's crucial to do as much research as possible. Scientists studied a volcano and found that shallow waters near the shore can reduce the power of tsunami waves. When the waves approach the shore, they slow down because of the sea floor, similar to how big ocean waves lose their force near the coast. The waves from the volcano eruption slowed down when they reached coral reef platforms in the shallow water. Surprisingly, waves from different eruptions combined, making the tsunami risk last longer and come from all directions. The most powerful eruption happened when seawater mixed with hot magma, causing a steam explosion. The first 4 blasts cracked rocks, letting a lot of water into the volcano. The study didn't focus on how the eruption started, but some scientists have a theory called the magma hammer, where the repeated movement of magma triggered the eruption. Even the seismic data showed a unique pressure drop during the biggest eruption, unlike most volcanic eruptions. This series of eruptions started in December, and while we don't know what set them off, it reminds us that volcanoes can be unpredictable. They wake up when magma flows through them, and anything can happen within. One of the study's authors, Dan Slayback, mentioned how surprising it was for such a massive event to happen with almost no warning. There were smaller eruptions leading up to January 15th, but scientists could use them to predict what might come next. Still, the volcano's immense power was astonishing. The size of the final eruption surprised many, with Slayback calling it a once-in-500 years event for the region, if not the world. The death toll could have been much worse, but a quick local response and fewer tourists due to the pandemic helped. The eruption also happened during the day, which reduced casualties. Tonga's main city was protected by an island and a lagoon, which acted as a natural barrier against the tsunami. Krakatoa's eruption in 1883 was a historically significant and highly destructive volcanic event. The eruption occurred in the Sunda Strait, located between the Indonesian islands of Java and Sumatra. Unlike most other volcanic eruptions, which are often forgotten over time, Krakatoa's cataclysmic explosion became renowned for its devastating consequences. Krakatoa was a stratovolcano, characterized by its composite structure formed through repeated eruptions of lava, ash, and volcanic materials that accumulated in layers. Prior to the catastrophic 1883 eruption, the volcano exhibited signs of reawakening, including smaller eruptions and increased seismic activity. These were clear indicators of its growing activity, a result of molten rock moving within the Earth's crust. This movement generated seismic waves detectable by seismographs and suggested that magma was pushing its way to the surface, increasing internal pressure. The buildup of pressure and magma reached a critical point in August 1883, leading to an explosive eruption lasting from May to October. This Plinian eruption was among the most powerful in recorded history, receiving a volcanic explosivity index rating of 6. It released an estimated 20 million tons of sulfur dioxide into the atmosphere, forming sulfuric acid aerosols in the stratosphere. These aerosols reflected sunlight, causing a temporary global temperature to drop of about 2.2 degrees Fahrenheit over 5 years. The eruption of Krakatoa in 1883 had devastating effects on the local human populations, resulting in a significant loss of life due to thermal injuries caused by the eruption's blasts and tsunamis. The death toll is estimated to have ranged from 36,417 to 120,000 people. This catastrophic event sparked renewed interest in the study of volcanology, highlighting the far-reaching impacts of volcanic eruptions on both local and global scales. Following the eruption, the volcanic island in the Sunda Strait was completely obliterated, leaving behind a submerged caldera. Over time, new volcanic activity reshaped the underwater landscape, giving rise to a new island known as Anak Krakatau, symbolizing the region's rejuvenation and rebirth of volcanic activity. This new island formed through the gradual accumulation of volcanic materials like lava and ash. Unlike typical volcanic islands that tend to disappear within a few years, Anak Krakatau remains an active and dynamic volcano. It serves as a testament to the ongoing tectonic forces and the Earth's constant crustal movement. While Anak Krakatau has displayed various levels of eruptive behavior over the years, it has not reached the scale of the 1883 Krakatoa eruption, allowing local communities to coexist with the active volcano. Furthermore, the region has experienced unpredictable volcanic activity, as seen in the 2014 to 2015 submarine eruption near Hungatanga. This eruption occurred underwater and gradually built up until breaching the ocean's surface, creating a visible landmass. Shield volcanoes, with their wide profiles and fluid lava eruptions, play a distinctive role in shaping landscapes. The Hawaiian Islands, home to renowned shield volcanoes like Mauna Loa and Kilauea, serve as examples of these geological features. These volcanoes have been actively shaping the Hawaiian terrain through their ongoing eruptions, contributing to the creation of new land. The 2018 eruption of Kilauea in Hawaii was a devastating natural disaster that had a profound impact on the Lower Puna district and its residents. This unexpected fissure eruption, which began on May 3rd and continued until August 6th, resulted in the destruction of over 700 homes and the burial of entire subdivisions under layers of lava. Thousands of residents were forced to face displacement and the daunting task of rebuilding their lives in the aftermath. The eruption had far-reaching consequences, as it led to large lava flows covering land southeast of the Kilauea volcano, causing irreversible changes to the park's summit area. The event was characterized by tens of thousands of earthquakes, towering ash plumes, and a massive collapse of the Kilauea caldera, creating a series of disastrous events. The eruption took scientists by surprise due to its unexpected nature, with lava, ash, and sulfur dioxide plumes making its volatile character evident. NASA and partner satellites played a crucial role in monitoring eruption patterns and atmospheric impacts. The event also served as an opportunity to evaluate instruments estimating lava flow rates and volume. In contrast to the Kilauea eruption, cinder cone volcanoes, characterized by their steep, cone-like shape, are smaller yet powerful members of the volcanic family. They result from explosive eruptions driven by the release of gas and ash, creating plumes of ash and immediate impact on their surroundings. Paricutin in Mexico is a notable example, showcasing how these volcanoes can suddenly emerge and unleash their destructive power. Stratovolcanoes, on the other hand, are known for their towering heights and steep slopes, with a composition of alternating layers of lava, ash, and other volcanic materials. They have the potential for explosive eruptions that can send ash and debris high into the atmosphere, affecting landscapes far beyond their immediate vicinity. The far-reaching consequences of stratovolcanoes' eruptions highlight their powerful and hazardous nature. Two of the most famous stratovolcanoes in the world are Mount St. Helens in the United States and Mount Fuji in Japan. Mount St. Helens erupted in 1980, causing death and extensive damage. Mount Fuji, Japan's tallest mountain, is also an iconic stratovolcano. What many people don't realize is that Mount Fuji, although its last eruption was in 1707, is still an active volcano, and its 1707 eruption had a profound impact on Japan. The 1707 eruption of Mount Fuji, which occurred between December 16, 1707 and January 1, 1708, covered nearby towns and cities in ash and debris, disrupting agriculture, causing food shortages and economic instability in affected areas. One of the most significant events in Earth's history was the volcanic winter of 536, which cast the world into darkness and cold temperatures for an extended period. The exact cause and origin of this event remain mysterious, but it had far-reaching consequences, affecting regions as distant as China and the Middle East. The volcanic winter led to a substantial cooling of temperatures, causing crop failures, food shortages, and the emergence of the plague of Justinian, which claimed millions of lives. The event's impact was profound and devastating. Today, we might think that such a catastrophic event couldn't happen again. However, Hungatanga, a powerful volcano, has experienced recent eruptions and is susceptible to another massive eruption, potentially plunging the world back into catastrophic times with famines, diseases, and other challenges that we might struggle to overcome. So, the sudden cracking of the world's biggest underwater volcano is a stark reminder of the Earth's power and unpredictability. While the challenges are immense, humanity has a history of resilience and innovation. Share your thoughts in the comments. Could we face such a crisis and still prevail? If you enjoyed this video, give it a thumbs up and subscribe to our channel. Stay tuned for our next exciting exploration. See you in the next one.